looking at interest calculations in more detail. So, you got simple interest. If you hear someone talk about simple interest, that is interest equals the principal. P is often used for the principal, that's the amount that you invest, times the rate. So invested at 10% per year times the number of years, right? And that calculates the interest that you earn. It's all percentages, okay? You might hear, like, when people talk about the interest rate going up, it's always a percentage. This is simple interest, so that would be a case where you have an investment. After, you don't get the interest till after the time period is up. If it's 1 year, they send you a check for that interest, you will send it. Compound interest is where this amount that you earn at the end of the year goes back with the principal that you invested. You don't touch it. So now that's in the account, and the whole thing, the original, and the interest that you just earned, gets interest for the next year. Okay? Then you earn the interest, it goes back in, that whole thing gets interest for the next year. So you're earning more interest than, like, over, say, 3 years than just a simple interest. Because each year you're putting that amount back in. You're not going to spend it.
The result becomes the principal.
Of the next year, exactly.
It's a geometric sequence.
It is.
You add and multiply by the new one.
Yep. Okay, so that's, you don't have to come up with the formula. This basically, you don't even have to know this. This is on your formula sheet, right? We can find the 100% keeps the amount in there. And you add in whatever the interest rate is. Okay? We'll look at a different way of showing the amount in compound interest in a sec. So let's go back and fill in here. So we're investing 1,000 at a rate of 8% per year. Sometimes you'll see that in banks per A/A means per annum. We talked about that yesterday. That's the Greek word for year. Okay, so interest rates are always shown as a yearly amount. You can compare it better. In this case, it's compounded quarterly. So how do we deal with compounded quarterly? The equation needs to include the rate at which our money earns interest each time. So think about it. That annual interest rate, you do not get it every quarter of the year. So every quarter of the year, they're going to calculate the interest. Banks are not very generous, okay? So they will take all the money that you can give them in terms of if you're borrowing money, they're going to charge you higher interest than if you are investing money. In any case, that yearly amount, 8%, that's per year. So what would that rate be for 1 quarter of a year? 2%. So to get that amount that your interest rate that you're calculating, you have to look at how often it's compounded. So it's compounded quarterly. So now it's going to be 2% every quarterly is 3 months. Okay. So that means your investment of 1,000 needs to be, so we're going to have 100% plus 2%. You're going to need to multiply by 1.02 every 3 months. Every quarter of a year. Okay, so then notice how time in years is bolded here. So we're keeping time in years, not months. In any case, Y will be our value of the investment. A will be our initial amount invested. We've already figured out that our B will be 1.02. Okay. T is years. And we need to think about the T value. This 2% gets calculated every quarter of a year, compounded quarterly. So don't think about months because that's different unit from this. So in years, we calculate 2% every quarter of a year. Okay, so how would we show that more, a little nicer? Would be 1.02 to the 4t. Okay. So if now we're told that we're going to invest for 5 years, then 5 is our t. So the exponent's going to be 20. So 1,000, bracket 1.02, close the bracket, exponent 20. And these are all money, so round to the nearest cent, 2 decimal places, unless we told otherwise. That's not bad. We just made $485.95. It is these days very difficult to find something, an investment of 8% per year.
And it's all in on there.
It's hard to get that high. Yeah. Interest rates for earning money are lower.
How low? No.
I don't know. I don't know.
That was a loan. They could like get 8%. Do you think we could jack that up a little bit to 20?
Well, because after the pandemic, so you may have heard on the radio or TV or whatever, the news that the Bank of Canada has lowered the interest rate, so the base and the primary interest rate, because they lowered it during the pandemic to help people out, and that's part of the reason why house sales have increased, because that affects mortgage rates. That means the rates for mortgages have gone down as well, so more people are wanting to buy. So that's going to have be a little tougher later this year, because now the interest rates are going to start going up again, and that's always reflected in mortgage rates. Mortgage is just a big loan, right? So the interest rates tend to be a bit lower on a mortgage because you have a house as your collateral. You can't pay, they'll take your house, basically. Whereas if you went to just buy a loan for a car, I don't know, it's probably cheaper to go to a dealership.
Cars is finance. It's totally financed options, so you can get a loan probably.
Yeah, you can go through the dealership so much easier, but if you just wanted to loan for, I don't know, random things, the interest rate may be higher than the house. You have to have something as collateral for it that they can take away if you don't pay it.
Or if it's credit card debt, then they just rack it up and rack
Credit
it up.
card debt is very high.
Until your life is ruined.
Yeah.
Because capitalism sucks sometimes.
Okay, so I want to just, if you have your own paper, just want to show you. Okay, noise level. Okay, so take a look at that form. That's really how often we show the compound interest equation. So basically, an exponential equation, just like we already did. Instead of, so if we show what we had before, okay, so A would be your principal. B, remember we had to figure that out. We had to go 100% plus the interest rate for compounding period. This shows it, right? That's equivalent to 100%. This is the interest rate per compounding period. So you have to figure that out. If it's compounded more than once a year, you have to divide, okay, into how much, what percent it is for that particular compounding period. I've never heard of an investment that takes 2 years before it compounds, or more than 1 year. It's always a year or half a year. Maybe, I'm not sure. As I said, I don't have a whole lot of investments. N is the number of times it's compounded. So remember, we ended up getting 4t in that last question because it compounded for that one every quarter of a year. Okay? Well, N here, if we then know how many years, then if it's compounded, say, quarterly, 4 times a year, for 5 years, that's going to be 20. Okay, so that will figure it out. So this is more useful when you're actually just calculating the final amount. Okay, sometimes we call it the accumulated amount. Okay, but certainly in terms of exponentials, you use what's on your formula sheet. Just wanted to do this question so you can compare what happens as we compound more frequently. So this one, we're going to invest $500 at 6% per year for 5 years. But we're going to compare 4 different investments. One where you compound annually, then semi-annually, then quarterly, then monthly. So some of your equation changes and some doesn't. Obviously, you're investing the same amount. But now your interest rate is 8%. As a decimal, it's 0.08.
It's the same.
Why 8? It's in the 0.6.
Oh, 6. Sorry, I was thinking the last question. A is like Y.
Yeah.
Oh.
Right? Capital A is like Y. Middle A is like P.
Amount. That's the amount you have.
I didn't put Y in here, but Y is. Accumulated means you keep building it, right? So that's often how we phrase it. So that's like Y. And this is like T over T. Okay, so 500 times 1.06, so it's 6% per year. So I had 8% from the last question and I had that. So per year, so it compounds once a year for 5 years. So N is 5 times once a year, so that's going to be 5. Okay, so calculate that and round to the nearest bit. So, how much interest was earned? $669.11? Yeah, you got to take the difference, right? The amount we invested to the final amount and subtract it. So sometimes they might just ask you that, right? And so you calculate the accumulated amount and subtract what you invested. So you subtract 500, you made $169.11 by putting it in the bank. Okay. Semi-annually, so that's going to be 0.06 divided by 2, which is 0.03. Okay, so I'm going to have A equals 500 times 1.03. But now your N, semi-annually, means it calculates interest twice a year, and again for 5 years. So 5 years times twice a year is going to be 10. Okay. So now calculate that. So you earned a little bit more. Same amount invested, same time period of 5 years, but you compounded more frequently, twice a year instead of once a year. So earned a little bit more interest, $171.96 on that one. Quarterly, 6% per year divided by 4. And N would be, so quarterly, 4 times a year for 5 years. So 5 times 4 is 20 times. It's going to calculate interest. You think you'll earn more or less interest? More. Because you haven't done anything different. You haven't invested any more money for a longer period of time, but that money that you make each time it calculates goes back in with the original, so it keeps building on itself.
I want to invest. What do I invest like $500 at Graham's number percent interest?
I don't know. I can't do it.
Compounded every plank time.
I don't know. Go for it if you can find it. Okay, so one thing that sometimes students do is they remember to do the N, for example, but forget to do the 1 plus the interest rate per compounding period. Let's look at the difference. If I forgot and I just put 1.06 and then raise it to the exponent 20, whew, that's a lot of money just made for 5 years. That's $1,603 for a $500 investment. Likely that's not going to happen, right? That's more than triple, exactly. So be aware of that. Always check. You have to do both the inside and the exponent, not just one, both of them. Okay. And then monthly, let's compare that one. And would be 5 years, 12 times a year, that's 60. So 500 times 1.005 to the 60. This is the one if you forgot to divide and you did 60 up here. Oops, no, I want to do this. Let's look at what it would be. It would be $16,493. So even though you're not investing and you don't have maybe, you're not thinking about that kind of thing, still think about, does that make sense that someone can invest just $500 and make, in that case, about $16,000 in 5 years? That's
Now think about the people who bought Amazon stocks in the 90s.
So just be careful on that. So let's do the actual calculation. If that was the case, I might not be here, right? Just salary. Okay, so each question here, I've compounded more frequently, and my accumulated amount has gone up. Okay, so the more time you compound, the more money you make. Listening, please. In real life, you may not have the choice. Like it might be one investment for a certain time period at a certain rate, at a certain compound. You might not be able to say, oh, can I compound quarterly? You may not have that option. But in comparison, that's what's going to happen. And obviously, if it's at different rates, that has an effect, right? Even if one's compounding more frequently, if it's at a lower rate, then maybe that's not going to help you. Okay? So that's compound interest.